When selecting a receptacle for a welder that is rated for 48 amps and operates on a 208 volts 2-pole supply, a 250 volts 50 amps receptacle is appropriate. The receptacle should have a slightly higher current capacity than the welder's rated current to ensure safe operation and to provide a margin of safety. Now let's move on to the circuit breaker. The National Electrical Code, or NEC, permits the overcurrent protection device, or OCT, such as a circuit breaker, to be rated up to 200% of the welder's rated current. Given a welder rated at 48 amps, multiplying this value by 200% yields 96 amps. However, it is crucial to consider the rating of the receptacle being used in the circuit. Since the receptacle is rated for 50 amps, the circuit breaker must be rated at or below this value to protect the receptacle from overload. Therefore, a 100 amp circuit breaker cannot be used in this scenario because it exceeds the receptacle's maximum current rating. The optimal circuit breaker size is 50 amps. This provides adequate protection for the welder while also complying with the NEC guidelines and respecting the current rating of the receptacle. To summarize, firstly, determine the welder's rated current, which in this case is 48 amps. Secondly, select a receptacle with a current rating slightly higher than the welder's, such as the 250 volts 50 amps receptacle. Thirdly, calculate the maximum allowable circuit breaker size based on the NEC 200% rule. In this case, 48 amps multiplied by 200% equals 96 amps. Fourthly, ensure that the circuit breaker rating does not exceed the receptacle's rating. Since the receptacle is rated for 50 amps, the circuit breaker must be 50 amps or less. Finally, choose a circuit breaker that provides adequate protection for the welder while complying with both the NEC requirements and the receptacle's rating. In this case, a 50 amp circuit breaker is the best choice. It is important to always consult the NEC and local electrical codes for specific requirements and regulations in the area. These codes may provide additional guidance or restrictions on circuit breaker and receptacle sizing for welders. Additionally, it is essential to consider the welder's duty cycle. The duty cycle is the percentage of time during a 10-minute period that the welder can operate at its rated current without overheating. If the welder has a low duty cycle, a smaller circuit breaker may be sufficient. However, if the welder has a high duty cycle, a larger circuit breaker may be necessary to prevent nuisance tripping. When selecting a circuit breaker, it is also important to consider its interrupting rating. The interrupting rating is the maximum amount of current that the circuit breaker can safely interrupt without being damaged. The circuit breaker's interrupting rating should be high enough to handle the maximum fault current that could occur in the circuit. This information can typically be found on the welder's nameplate or in the manufacturer's specifications. The information includes the rated primary current, the open circuit voltage, the input voltage, and the rated kVA, which is the kilovolt amps. The rated primary current is the amount of current the welder draws from the power source under normal operating conditions. The open circuit voltage is the voltage present at the welding electrode when the welder is turned on but not actively welding. The input voltage is the voltage required to power the welder, which in this case is 208 volts. The rated kVA is the apparent power consumed by the welder. It is important to verify the welder's input voltage requirements to ensure compatibility with the available power supply. Using a welder with an incorrect voltage can damage the equipment or create a safety hazard. In addition to the NEC and the welder's specifications, it is essential to follow the manufacturer's recommendations for circuit breaker and receptacle sizing. The manufacturer may have specific requirements or recommendations based on the welder's design and performance characteristics. These recommendations should be carefully considered when selecting the appropriate circuit protection and connection components. It is always advisable to consult with a qualified electrician to ensure that the circuit breaker and receptacle are properly sized and installed according to all applicable codes and regulations. A qualified electrician can assess the specific requirements of the installation and provide expert guidance on selecting the appropriate components and wiring methods. Proper grounding is another critical aspect of welder installation. The welding machine, receptacle, and circuit breaker panel must be properly grounded to protect against electrical shock hazards. Grounding provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. Grounding should be performed in accordance with the NEC and local electrical codes. The grounding conductor should be sized appropriately for the circuit and securely connected to the grounding electrodes. Regular inspection and maintenance of the electrical system are essential to ensure safe and reliable operation of the welder. This includes checking the circuit breaker for proper operation, inspecting the receptacle for damage, and verifying the integrity of the wiring connection. Any signs of wear, damage, or overheating should be addressed promptly to prevent potential hazards. When installing the receptacle, ensure that it is properly mounted and secured to prevent accidental disconnections. Use appropriate wiring methods and connectors to ensure a reliable and safe connection. Avoid overloading the circuit by connecting other loads to the same receptacle. Dedicated circuits are generally recommended for welders to prevent voltage drops and ensure consistent performance. Voltage drops can occur when the circuit is overloaded, causing the welder to operate inefficiently or even damage the equipment. By providing a dedicated circuit, the welder can receive the full voltage and current it needs to operate properly. In addition to proper circuit breaker and receptacle sizing, it is also important to consider the type of wiring used for the welder circuit. The wiring should be sized appropriately for the current carrying capacity of the circuit and should be suitable for the environment in which it is installed. For example, if the welder is used in a damp or wet location, moisture-resistant wiring should be used. The wiring should also be protected from physical damage. Conduit or other protective measures may be necessary to prevent the wiring from being damaged by impact, abrasion, or other hazards. When selecting wiring, it is important to consider the ampacity or current carrying capacity of the wire. The ampacity of a wire is determined by its size, material, and insulation type. The NEC provides tables that list the ampacity of various types of wires under different conditions. It is essential to select wiring with an ampacity that is sufficient to handle the maximum current that the welder will draw. In addition to the ampacity of the wire, it is also important to consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs along the length of a wire due to its resistance. Excessive voltage drop can cause the welder to operate inefficiently or even damage the equipment. The NEC provides guidelines for limiting voltage drop in electrical circuits. To minimize voltage drop, use larger gauge wiring and keep the circuit length as short as possible. It is also important to ensure that all connections are tight and secure to minimize resistance. The type of welding process being used can also influence the circuit breaker and receptacle sizing requirements. For example, shielded metal arc welding, or SMAW, also known as stick welding, typically requires a higher current than gas metal arc welding, or GMAW, also known as MIG welding. Similarly, gas tungsten arc welding, or GTOR, also known as TIG welding, may have different current requirements depending on the materials being welded and the welding parameters used. Always consult the welder's specifications and the NEC guidelines to determine the appropriate circuit breaker and receptacle sizing for the specific welding process being used. When working with electrical equipment, it is essential to follow all safety precautions to prevent electrical shock hazards. Always energize the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical equipment in damp or wet conditions. If you are not comfortable working with electrical equipment, it is best to hire a qualified electrician to perform the installation. In summary, selecting the appropriate circuit breaker and receptacle for a welder requires careful consideration of several factors, including the welder's rated current, the NEC guidelines, the receptacle's rating, the welder's duty cycle, the interrupting rating of the circuit breaker, the welder's specifications, the type of wiring used, and the welding process being used. By following these guidelines and consulting with a qualified electrician, you can ensure that the welder is safely and properly installed. Remember that electrical work can be dangerous and should only be performed by qualified individuals who are familiar with the applicable codes and regulations. If you are unsure about any aspect of the installation, it is always best to seek professional assistance. Proper planning and execution are essential to ensure the safe and reliable operation of the welder and to protect against electrical hazards. These safety measures and proper installation practices not only safeguard individuals but also contribute to the longevity and efficient functioning of the welding equipment. Consistent adherence to these standards creates a secure working environment and prevents potential accidents or equipment malfunctions. In addition to the technical aspects, it is important to emphasize the importance of regular maintenance and inspections of the electrical system. Routine checks can help identify potential problems before they escalate into serious issues. This includes inspecting wiring for wear and tear, ensuring connections are tight and secure, and verifying the proper functioning of circuit breakers and receptacles. Addressing any identified issues promptly can prevent costly repairs and ensure the continued safe operation of the welding equipment. Remember that a well-maintained electrical system is a key component of a safe and productive welding environment. Furthermore, ongoing education and training are essential for individuals working with electrical equipment. Staying up to date with the latest codes, regulations, and best practices ensures that electrical work is performed safely and effectively. This includes understanding the proper use of personal protective equipment, the correct procedures for de-energizing circuits, and the identification of potential hazards. Investing in ongoing education and training demonstrates a commitment to safety and professionalism. Finally, it is important to recognize that electrical safety is a shared responsibility. Everyone in the workplace should be aware of potential electrical hazards and take steps to prevent accidents. This includes reporting any unsafe conditions, following established safety procedures, and participating in safety training programs. By working together, we can create a culture of safety that protects everyone from electrical hazards. In conclusion, selecting the appropriate circuit breaker and receptacle for a welder is a critical aspect of ensuring safe and reliable operation. By carefully considering the factors discussed and following all applicable codes and regulations, you can protect yourself, your equipment, and your workplace from electrical hazards. Remember to prioritize safety and to seek professional assistance when needed.